Hello again. In this segment of this lesson, I'm going to focus on domain of rational functions. So if you have a rational function or a fractional function or expression, and you want to find the domain without looking at the graph. So we don't have the graphs of those functions, but we should be able to look at the symbolic form and decide what the domain of this function is. So to decide what the domain is, I always have to look at what value of x I can't plug in there. What are my restrictions? I think that's a good way to think about any function, whether it's rational or not. Ask yourself, what are the restrictions on this function? What kind of x values I can't plug in there? And you're going to find out that any rational function or rational expression, the denominator cannot be 0. So that's your restriction. I cannot have a denominator of 0. So since I can't have the denominator of 0, then I would take the denominator and say, for this not to be equal to 0, okay, and actually I should put a slash through it because it doesn't equal to 0. But my first step is to make it equal to 0 and then see what x value I shouldn't have. So that gives me the exception right there. So that would be easier to do. So I take the denominator, set it to equal 0, and then solve that equation. So I'm going to add 1 to both sides. I get 2x equals 1, and then I'm going to divide by 2. So that will give me x equals 1/2. But remember, x equals 1/2, when you plug it in here, makes it 0. So that's your exception right there. And you're going to say x cannot equal to 1/2. So if x cannot equal to 1/2, and we're talking about what is the domain, then the domain would be all real numbers except 1/2. So if you want to do this in writing, you're going to say it's all real numbers except 1/2. But most of the time, you'll be asked to write the domain in interval notation. So how would you write the domain in interval notation? You're going to go with, look at the number line first, and say, well, 1/2, if that's 1, 1/2 is right there. And we can't have 1/2. So 1/2 is a white circle here, an open circle. Well, we can have everything to the left, everything to the right of 1/2. And this interval going all the way from negative infinity to 1/2, so negative infinity, comma, 1/2. But remember, you have to open it at 1/2 because 1/2 is excluded and means we use parentheses, not brackets. At infinity or negative infinity, remember, it's always an open interval. And then we have to take the union and list the second interval, which goes from 1/2 to infinity, and it's open at both ends. So by writing the interval the domain in interval notation like this, this shows that we're only excluding the number 1/2, and we're including everything else on the real number line. So that would be your domain, right, like this in interval notation. And you may be asked to write the domain in many different ways. You could write it in just an algebraic form. You could write it in interval notation. But in this class, I want to focus on interval notation. OK, so I'm going to move to the second function here, f of k equals k plus 7 over 2k. Remember that the numerator could be any number you want, even could be 0. So I'm not really worried about the numerator when I want to find the domain of a rational function. I just want to focus on the denominator. So my first step to find the domain of this function is take the denominator and make it equal to 0. Because I want to find what values of k will make the bottom 0 so I can avoid them, so I can exclude them. And if 2k is equal to 0, dividing both sides by 2 will give you k equals 0. And that means if k is 0, then the expression will be undefined, be 2 times 0. So you have a denominator of 0, expression is undefined, so we can't have 0. And again, the domain will be all real numbers. And I'm going to use this big R for real numbers, except 0. And if I want to write it in interval notation, I would take everything and just exclude 0. So remember, look at the number line, and you have 0 right there. You're going to exclude 0, but you're going to include everything to the left, everything to the right. And always with interval notation, you have to go from small to large, so left to right, negative infinity to 0, open at both ends, union 0 to infinity. That would be the domain in interval notation for f of k. Okay, so now let's move to f of r and do the same thing. So I'm going to erase this part right here. And then take f of r. Okay, so the denominator cannot be 0 when I want to find the domain again. So I take the denominator, which is 2r squared minus r minus 1, and set it to equal 0. Well, how do I solve this equation now? I want to solve it for r. But remember, this equation is not linear equation. It's a quadratic equation or a second-degree equation. And if you remember how to solve second-degree equations, the first method to solve them is factoring. So I'm going to try that. I'm going to factor the left side. So 2r squared factors to 2r times r. The negative 1 is going to factor to negative 1 times positive 1, but I don't want to put my signs yet. Remember, since the last term is negative, your signs will be positive, negative, or negative, positive. But to make sure I got this right, I'm going to look at the outside. The outside is 2r, and here 1r. And I'm looking at the difference because one of them has to be positive, the other one has to be negative, but I want a negative middle term. So I'm going to make this negative. The 2r has to be negative, so to make that negative, I have to use a negative 1 right here for the 1. And this one has to be positive, gives me 1r, negative 2r, plus 1r is negative 1r. So make sure you got the right factoring done. So now they're factored correctly. And remember, the zero factor property says that if you multiply any two numbers and get 0, that means at least one of them has to be 0. So we're going to use the zero factor property to solve this quadratic equation. So I take 2r plus 1 and set it to equal 0, or r minus 1, set it to equal 0. And remember the meaning of or, it could be both as well, not just one or the other, but also both. So solve each resulting equation, subtract 1 from both sides. So you got 2r equals negative 1. Divide both sides by 2. Then r equals negative 1/2. And that means if r is negative 1/2, the denominator will be 0. So actually, r is equal to negative 1/2 is a restriction. You cannot have that. And then here, add 1 to both sides to solve the second equation. So you get r equals 1. And again, you want to say, well, r equals 1 makes it 0. For this function to be defined, then we can't have 1, we can't have negative 1/2. So those are the restrictions on the domain of the function. Now, how do I write the domain in interval notation? Well, the best way, I think, to do it is to look at the number line and exclude negative 1/2. So I have 0 here. If that's negative 1, negative 1/2 is right here. And exclude that. And then exclude 1. So I have 1 right here, exclude 1. But everything else on the number line is your domain. Let's use this. So everything here in red is the domain of that function. And so how do we write it? Well, it looks like we have 1, 2, 3 interval intervals that we have to take the union of. And so to write the domain of this function, I'm going to go with first interval is negative infinity to negative 1/2, and excluding negative 1/2, union going from negative 1/2 to 1, and also exclude 1. So you're excluding both negative 1/2 and 1, union going from 1 to infinity. So that would be the domain of this function. And then finally, I'm going to look at the domain of f of t right here. And if you look at the denominator and ask yourself, what value of t will be restricted? Is there any value of t that gives you 0? And if you look at t squared and think of t squared is always a non-negative number, so this can never be negative. Could be 0, smallest, because 0 squared is 0. And if you take t to be negative 1 squared is 1. So any number you take for t is going to be either positive or 0. So right there, when you see that I have addition with something squared in the denominator, that means any value I want, I can plug in there. I have no restrictions whatsoever on that. So for this one, the domain will be all real numbers, or in interval notation, all numbers between negative infinity and infinity. So remember what you need to do, again, to put this all together, to find the domain of rational function or expression is to plug in the, it's to make sure that the bottom or the denominator of those fractions is not a 0. So that's what you want to think about. You don't even need to look at the graph of that rational expression or rational function.